Hey guys, we are going to talk about section 4.1 and 4.2. So we are jumping into slope this chapter. So we will go ahead and get started with some of the background concepts. So in section 4.1, we are going to be working a lot more in the coordinate plane. So it's important to remember several key things about the coordinate plane. So first of all, let's review these points here. We have points A, B, C, and D. As I look at point A, remember that my coordinates are always going to be listed x, comma, y. So my first number is going to tell me how many units to move to the right or left of the origin. So point A is at -4, +1. So 4 to the left of the origin, 1 above the y-axis or the x-axis. For point B, from the origin, we're going to move right 1 and down 2. So the coordinates of this point would be 1, 2. Point C, from the origin, I'm going to move 3 to the right and up 2. So the coordinates are +3, +2. And point D is on the y-axis, so I'm going to go over 0, but up 3. You'll notice that this point is labeled here because my scale is counting by 2s, but I'm only labeling every other line. So, or I'm sorry, my scale is counting by 1s, although I've only labeled every other line. So keep an eye on your scale when labeling your coordinates. But that is review. I know you guys are good to go on that. So let's review a little bit more about the coordinate plane. We have divided it into 4 quadrants, and this isn't something we've talked about yet this year. So when you're looking at positive x values and positive y values, that puts you here in quadrant 1. In quadrant 1, both coordinates are positive, and an example of that would be the point 4, 5. From the origin, I move right 4 and up 5. Now our quadrants move counterclockwise around, and so to the left I have quadrant 2, and you'll notice that all of my x coordinates are going to be negative, but all of my y coordinates will still be positive. So an example of a point in quadrant 2 would be -2, 2, meaning from the origin I move left 2 and up 2. As I continue around counterclockwise, I move down to quadrant 3, where my x values are negative and my y values are negative. So an example of this, of a point in quadrant 3 would be -3, -4. So from the origin, I move left 3 and down 4. And as I finish counterclockwise trip around the coordinate plane, I land in quadrant 4, where my x values are positive, but my y values are negative. So an example would be the point 5, -6. So from the origin, I'm moving right 5 and down 6. So really, most of our work so far this year and for a good portion of the year will take place in quadrant 1. So that's easy to remember. And then just remember to move in a counterclockwise direction to name the remaining quadrants. So using what we just talked about, you could tell which quadrants these points are in without even graphing them. So thinking about in the top right quadrant of our coordinate plane, we have positive x values and positive y values. I might look for a point that has 2 positive values, and I notice the point 4, 9, so this would be an example of a point in quadrant 1. I also have the point 5, 0, so I notice I don't have any negative values here. So I know for this point, if it's 5, 0, I'm going to go over 5 and up 0, which means this point is on the x-axis. So this point, if it's on an axis, is generally not considered to be in any of the 4 quadrants. So this would be considered an x-intercept because it's on the x-axis. So as I continue looking down for more quadrant 1 points, I see that the point 0, 4 has no negatives, but I know that going over 0 and up 4 means that this point is going to be on the y-axis, which means that it won't be in one of the 4 quadrants. Rather, it would be a y-intercept. So let's look through quadrant 2. Moving counterclockwise around my coordinate plane that we talked about before, we said in quadrant 2 we'll have a negative x value and a positive y value. So let's look for points with a negative x value and a positive y value. So negative 4, 6 would be an excellent example of a point in quadrant 2. Here I have a negative x, but also a negative y. Here I have a positive x and a negative y. So no more points in quadrant 3, or in quadrant 2, but as I move around to quadrant 3, I'm looking for a negative x and a negative y value, which would be a good example here, negative 1, negative 6. And finally, if I have a positive x but a negative y value, that's going to put me in quadrant 4. Next, we will just practice plotting a point and describing the location. So if I need to plot point B at -3, -3 from the origin, I'm going to go left 3, paying attention to my scale, and I'm going to go down 3, put my point exactly there, in the corner of that grid, and label it point B. So point B would also be in quadrant 3. Remembering this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Our next topic from this section, we will be asked to graph the function with the given domain, then identify the range of the function. So here is my function, it's my equation here, y equals 2x minus 5, and you're probably remembering from chapter 3, we talked about taking equations and writing y as a function of x, or we talked about this being function form. So now I'm going to take this function and use these values for my domain. So to help me organize, I'm going to list my domain values, which I remember to be my x values, here in a table so that I can find the corresponding y values and graph these points. So to do this, I'm going to substitute into my function. So I'm going to start by substituting -2 in for x. So that will be 2 times -2 minus 5. 2 times -2 is -4, and -4 minus 5 is -9. So that's the first point that I will plot on my graph. Starting at the origin and paying attention to my scale, I'm going to go left 2 and down 2, 4, 6, 8, 9. Okay, the next value I'm going to substitute in is -1. So I will put -1 into my function for x. 2 times -1 is -2, and -2 minus 5 is -7. So this is the second point that I will plot from the origin. I'm going to go left 1 and down 2, 4, 6, 7. As I'm plotting these points, I'm looking for a general slope or pattern to my points. And if I find I don't have one, then I should go back and double check my work. So next I will substitute 0 into my function. So I will put 0 in for x. 2 times 0 is 0. 0 minus 5 is -5. And I'm noticing my y values are increasing by 2. So I definitely seem to be following a pattern. So to plot this point, I'll start at the origin, go over 0, and down 2, 4, 5. So I can definitely see a consistent path. So as I substitute my last values, I will look for this line to move into quadrant 4. So as I substitute 1 into my equation, y equals 2 times 1 minus 5. 2 times 1 is 2. And 2 minus 5 is -3. I have my fourth point to plot, 1, -3. So from the origin, I'll go over 1 and down 3. And finally, I'm going to substitute 2 into my equation. So I substitute 2 for x. 2 times 2 is 4. 4 minus 5 is -1, and I have my last point. So from the origin, I will go right 2 and down 1. I have now graphed the function, but I also need to identify the range of the function. Given this domain, my range will be my y values. And we talked previously in chapters 1 and 2 about when we list our range, we should go ahead and list our numbers in increasing order from least to greatest. So now I have my range. Now we'll look at some real-world context and what functions can look like in a real-world problem, how we can solve with a graph and a table. So the table shows some of the moons of Jupiter, their mean distances from Jupiter in 1,000 kilometers, and their orbital periods in Earth days. Graph the data from the table. Does the graph represent a function, y or y not? So for this, we are going to recall back in chapters 1 and 2 again, when we first talked about functions, and we said that for every input, I can only have one output. So that's something we'll keep an eye on as we are graphing this data. Let's put our first ordered pair here. So we're looking at the first moon. We have the mean distance and the orbital period. And in my graph, I have mean distance listed on the x-axis and the orbital period on the y-axis. So to plot this first point, I'm going to go over 422 and up 1.8. So I notice that my scale here is 300. So I'm going to have to estimate in between 300 and 600 about where 422 would be. So if this is 300, then I'm going to go about a third of the way over. And now I need to go up 1.8. So on my y-axis, I am counting by 4s. So 1.8 is a little less than 2. So I will plot my first point here, and I might label it I to help me remember which moon this is. Okay, next I'm going to plot 222 7/10. So I'm going to go over 222 and up 7/10. So 222 is going to be less than 300, and 7/10 is going to be even less than 1. So I'm going to label this point with a T. My third moon, I need to go over 1070. So halfway in between would be 900. So I'm going to come about a third of the way over between 900 and 1200. And we will go up 7.2 days. And I will label this with a G. For my fourth moon, we're going to go over 1,883. And I'm going to go up 16 and 7/10. And I'll label this with a C. And for my final moon, I'm going to go over 671 and up 3.6. And label that with the E. So right now we want to know, does the graph represent a function, y or y not? So in this case, the main thing to remember is that to be a function, each input has to have one output. So this graph would represent a function because each input has exactly one output. So we